Let's practice finding the distance between 2 points on a coordinate plane together. For each of these practice problems, let's go ahead and sketch the locations of each of these ordered pairs, and then let's go ahead and use absolute values to go ahead and determine the distance between each of these ordered pairs. For number 1, we have the first point of 4, 2. So if we go ahead and move this dot to the origin, we have to go about 4 units to the right and then 2 units up, so maybe something like this. And that's going to be our point A. And then our second point is going to be B, which is going to be -6, +2. So if we go ahead and plot that one, we're going to start at the origin. We're going to move about 6 units to the left and then 2 units up. So we should put a dot maybe somewhere about here, right? So this is going to be point B. Now, since these 2 points are in different quadrants, what we're going to do is first notice, okay, we do have matching y values here. That is good. But let's go ahead and take a look at the x values, right? Those are going to help us find out the distance between these 2 points. So because these are in different quadrants, what we're going to do is we are going to add their absolute values. So when we're adding, it doesn't matter, but we're going to take the absolute value of 4 and then add the absolute value of -6. Okay, the absolute value of 4 is going to be 4. The absolute value of 6, or -6 rather, is going to be 6. And then 6 plus 4, or 4 plus 6, is going to be 10 units. Okay, so if you're going to say what's the distance between these 2 points of point A and point B, it would be 10 units. And we went ahead and saw that they are in different quadrants, so we add their absolute values. All right, let's check out number 2 now. For number 2, we have point C, which is located at -1, 7. So we start at the origin, move about 1 dot to the left or 1 unit to the left, and then move 7 units up. So maybe something like this in quadrant 2. And then for point D, we have -1, 3. So that starts at the origin and moves 1 unit to the left and then 3 units up. So maybe something like here. So C would be located up here while D is a little bit beneath it. And notice how they are in the same quadrant, right? And we could tell that by looking at their y values as well. So first of all, we notice that their x's do match here, right? These x values of -1, so that means we can find the distance of these pretty easily. And then we just take a look at the 7 and the 3. They're both positive, so they meant they were going to be in the same quadrant. Now, if they're in the same quadrant, to find the distance, we take the number that has the bigger absolute value. So we put 7 first, and then take away the absolute value of 3. That one has a smaller absolute value. Absolute value of 7 is 7. The absolute value of 3 is 3. So 7 minus 3, that's going to be 4. So we're going to have a total of 4 units between these 2 points of C and D. Let's look at number 3 now. For number 3, we have point E, which is going to be at 6, -5. So we'll start at the origin, move 6 units to the right, and then move 5 units down. So we're going definitely a little bit more to the right and a little bit less down. That's going to be point E. And then for point F, we have 6, -2. So we're going to start at the origin, move 6 units to the right, and then move 2 units down. And that's going to be point F. And so you can notice here that E and F are in the same quadrant. And let's go ahead and verify that. So they have matching x coordinates of 6. Right? So that means that they are going to be on top of each other or right above and below. And notice how their non-matching numbers, -5 and -2, are both negative. So that means they're in the same quadrant, right? If they're in the same quadrant, we're going to subtract their absolute values. The one that has a bigger absolute value is -5, and take away the one with a smaller absolute value, which is -2. The absolute value of -5 is 5. The absolute value of -2 is 2. 5 minus 2, that's going to be 3 units. Okay, so we can go ahead and say that we know that these 2 points, or these 2 ordered pairs, are 3 units away from each other. For number 4, we have these 2 points of A and B. For point A, we have -5, -2. So we're going to go ahead and take this point, start at the origin, maybe move 5 units to the left and then 2 units down, something like this. We're going to go ahead and label that point A. And then for point B, that's located at -9, -2. So we're going to start at the origin, then move 9 units to the left, and then 2 units down, maybe something like here. And that would be our point B. Okay, so notice that they're in the same quadrant. So let's go ahead and see if that makes sense. We have this -2 and -2. They have matching y values. Okay, so that means that they're going to be horizontal from each other, or left and right from each other. And then we're going to go ahead and focus on this -5 and -9. Since they're in the same quadrant, we're going to subtract their absolute values. So we're going to use the -9 first, just because it has a greater absolute value, and then put the -5 second. The absolute value of -9 is 9. The absolute value of -5 is 5. 9 minus 5, that's going to be 4. So we know these are going to be 4 units apart from each other. Here's number 5. For number 5, we have point C, which is going to be -3, 7. So let's start at the origin, move 3 units to the left, and then 7 units up. That would be over in quadrant 2. That's where we're going to put point C. And then for point D, we have -3 comma -6. That should be in quadrant 4. That's going to be 3 to the left and then 6 down. Maybe something like right around here. That would be point D, right? So let's confirm that they are in different quadrants. So we can see here that -3 and -3, these have matching x values, okay? So that means that they should be on top of each other or above and below. And then we go ahead and take a look at their non-matching numbers of 7 and -6. One's positive, one's negative, so we can confirm that they're in different quadrants. If they're in different quadrants, we're going to add their absolute values, so it doesn't matter which one we write first, just because we're adding. So it doesn't matter which order you do. The absolute value of 7 is 7, and the absolute value of -6 is 6. 7 plus 6 is going to be 13. So we're going to go ahead and write that these two dots, or these 2 points, are going to be 13 units away from each other. Here's number 6. For number 6, we're starting off with E, which is going to be 4.2 comma -2. So we'll start at the origin and move 4.2 units to the right, and then 2 units down, maybe something like here. That's located in quadrant 4. That's going to be point E. And then for point F, that's going to be 3.9 comma -2. So we'll start at the origin, move 3.9 units to the right, and then down 2 units. So it's very close to point E and F, these 2 points together. So I'm going to put F. They are clearly in the same quadrant because they're both in quadrant 4. We can also confirm that by saying, okay, -2 and -2, they have matching y values, so they should be next to each other. Okay, so we do now know, since their y values match, that these 2 points are left and right of each other, so we can focus on their non-matching x values. Now they're in the same quadrant, so to find their distance, we can just take the absolute value of the larger value of 4.2 and take away the absolute value of the smaller value, 3.9. The absolute value of 4.2 is 4.2. The absolute value of 3.9 is 3.9. And 4.2 minus 3.9 is going to be 0.3. So it's going to be 3/10 units away from each other. Now let's look at number 7. For number 7, we have point A, which is located at -4 comma 3.9. So we'll start at the origin, move 4 units to the left, and then 3.9 units up. So a little bit less up than to the left. That's going to be point A. Go ahead and label that one right over here. And then for point B, we have -4 comma -7.5. So we'll start at the origin, move 4 units to the left, and then 7.5 units down. So that's going to be somewhere down here, and that's going to be in quadrant 4. That's going to be B. Okay, so we can confirm here that they are on top of each other or above and below, just because this -4 matches for both of them. Their x values match, and when that happens, we know that they are going to be above and below each other. Okay, now we go ahead and look at their non-matching values. We have a 3.9 and a -7.5. So since one's negative, one's positive, they're in different quadrants. So we're going to go ahead and add their absolute values. When adding, we don't care which one's first. So we have the absolute value of 3.9 plus the absolute value of -7.5. The absolute value of 3.9 is still 3.9, and the absolute value of -7.5 is going to be +7.5. And if you add these 2 decimals together, we are going to get 11.4 units. That would be the distance between these 2 points. Here's number 8. For number 8, we have point C, which is going to be at 4 2/3, comma 5.5. So that's going to be in quadrant 1. So let's move to the right 4 2/3 and move up a little higher, 5.5 units. This would be point C over in quadrant 1. Okay. Then for point D, we have to go to 7 1/3, comma 5.5. So that's more to the right, and then it's going to be up. So something like this. Okay. So again, just estimating here, but we can see that point C and D both have a positive X and a positive Y. So they should both be in quadrant 1. They are left and right of each other, and that makes sense because they have matching Y values of 5.5. So again, they have matching Y values, so we know they're left and right of each other, so we can just focus on finding the distance between this 4 2/3 and 7 1/3. Okay, so they're in the same quadrant, so we're going to subtract their absolute values. So the absolute value of 7 1/3, and we're going to go ahead and take away the absolute value of 4 2/3. Now the absolute value of 7 1/3 is just 7 1/3, and the absolute value of 4 2/3 is going to be 4 2/3. Now there's different ways that you can do this, but I'm going to just convert both of these into improper fractions. So we can do 7 times 3, which is 21, plus the 1. That's going to be 22 over 3. Okay, same thing as an improper fraction. And then converting this 4 2/3, 4 times 3 is 12, plus the 2 is going to be 14. So we can go ahead and subtract 14/3 from 22/3. Luckily, we have common denominators, which is nice. So 22 minus 14, that's going to be 8. So we can go ahead and say that this is going to be the same thing as 8/3. And just for good measure, I'll turn this into a mixed number. You don't have to though. We're gonna say this is gonna be 2 2/3 units away from each other. So a little bit easier to kind of understand that it's less than 3 units if we convert it into a mixed number. All right, for number 9, we have point C, which is located at -2 1/4, comma, -4 2/3. So we start the origin, move 2 1/4 to the left, and then move 4 2/3 units down. So that's going to be in quadrant 3 where we have negative. So that's going to be where point C is. And then point D, we're going to be at -2 1/4. So we start the origin, move 2 1/4 units to the left, and then 2 3/4 units up. So it's going to be a little higher there. That's going to be point D. Okay, so they are in different quadrants, it looks like. And we can go ahead and confirm that these 2 points are above and below each other because they have matching x coordinates. So that confirms this with the -2 1/4. And let's go ahead and check out the non-matching numbers of -4 2/3 and this +2 3/4, right? So they're in different quadrants. So let's go ahead and add their absolute value. So the absolute value of -4 2/3, let's go ahead and add that to the absolute value of 2 3/4. Okay, now we're adding here, but the absolute values first we got to take care of. So this is going to be 4 2/3, and then this is going to be just 2 3/4. Okay, now when we're adding mixed numbers, this is a little bit more straightforward than subtracting. We don't have to borrow or anything, but we do need to find a least common denominator. I think 3 and 4 are relatively prime, so they meet at 12 for the first time. So we can multiply this by 4 and 4, multiply this one by 3 and 3, so they get common denominators. If we do that, we should end up with 4 8/12, and then we can go ahead and add 2 9/12. Okay, now if we're adding the 4 and 2, the whole numbers, that should equal 6. And then if we add 8 and 9, that's going to be 17, so that should be 17/12. Now 6 and 17/12 is the same thing as 7 and 5/12. Okay, so that's going to be 7 5/12 units. So make sure our final answer doesn't have an improper fraction inside of a mixed number. We have either or. So if you wanted to write your answer as 89/12, that would be also correct, written as an improper fraction. All right, last one, let's look at number 10. For number 10, we have these 2 points of C and D. For point C, we have -6 1/2, comma, +2 1/4. So start at the origin, move 6 1/2 units to the left, and then 2 1/4 units up, something like this. And we can go ahead and say that's going to be point C. And then for point D, we have 2 3/4 and then 2 1/4. So that's going to be 2 3/4 to the right, and that's going to be 2 1/4 units up somewhere over here in quadrant 1. We're going to go ahead and label that as point D. Notice how we have matching y values, which is why these 2 points are left and right of each other. And so that hopefully makes sense why these are matching y's of 2 1/4. So we can go ahead and focus on this -6 1/2 and this +2 3/4. They're in different quadrants, so let's go ahead and add their absolute value. So we have the absolute value of -6 1/2. Let's go ahead and add on the absolute value of 2 3/4. Okay, we're adding these, so we can go ahead and just take away their absolute values because this is 6 1/2 away from 0. This one's going to be 2 3/4 away from 0. Now, for adding, this is not going to be too bad. We just need common denominators. Now, 2 and 4 meet at 4 for the first time, so we just have to multiply this 1/2 by 2 over 2. Okay, and so 6 1/2 is the same thing as 6 2/4, and then 2 3/4 can just stay the same, just because it already had a 4 in the denominator. Okay, adding these whole numbers of 6 and 2, that's going to be 8. And then adding the numerators, 2 plus 3 is 5, so it's going to be 5/4. Now we have an improper fraction inside of a mixed number, just like in number 9, so we can rearrange this and say this is going to be 9 1/4 units. Okay, so that would be the distance between these 2 points of C and D, and we got this by adding their absolute values of their non-matching numbers, and we had to make sure we had common denominators to do so. All right, so there you have 10 different practice problems on finding distance on a coordinate plane. Even if you didn't have a coordinate plane, using absolute values will always work for you as well. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.